Today I'm going to walk you through the thermochemistry practice test B. This test only has 3 objectives. One has to do with Q equals MC delta T type problems, so you'll need this test taking tool. The next one has to do with phase changes. You'll need that test taking tool. The last one is a DP or distributed practice, and it's all about stoichiometry, so you'll want your stoichiometry roadmap. That has on the back side some specific instructions. Of course, you also probably want your periodic table. The first one is a Q equals MC delta T type problem. So when I'm reading through there, the specific heat of iron metal is 0.450 joules over grams degree Kelvin. It's okay if it says Kelvin or Celsius here. We can treat them the same because the space between a degree Kelvin and a degree Celsius are the same. What they want to know is how many joules of heat. I have to pay attention to whether they want joules or kilojoules. I'll also have to pay attention if they give me kilograms or grams. This one we want to know joules. My test taking tool says, need to know heat in calories or in joules? You cover this up and it simply tells you what to do. The mass in grams times the specific heat times the change in temperature. So this first one, although it's 3.25 kilograms, if I change that into grams, I put what I want to know, grams, over what I was given, kilograms. 1 kilogram is 1,000 grams. Ultimately, I just moved the decimal over 3 places. 1, 2, 3 for 1,000. My mass is 3250 joules. Specific heat is 0.450 joules over gram degree Kelvin or Celsius. We can use them interchangeably. The change in temperature that they're after is from -12 to 5. So that's a change of 17. The difference between them is 17 degrees Celsius. $32.50 times 0.45 times 17, 24,862.5. Now they asked for joules, and I could simply write J for joules, but I like to double check. This thing should have been grams here. That's my double checking, trying to figure out if I'm on the right track. That grams and grams cross out. Degrees Celsius and degrees Kelvin can cross out because there's the same distance between them. My answer is 24,862.5 joules. The next one also wants to know how much heat energy in joules is absorbed when 150 grams of ice is warmed from -27.8 to 12.1. So I'm also after heat. Heat is MC delta T. The mass of the ice is 150 grams. The specific heat of ice, specific heat, there's water, liquid, gas, solid, 2.09 joules per gram degree Celsius. Times the change in temp. The difference between -27.8 and 12.8, or 12.1, 27.8 minus 12.1, it's a difference of 15.7 times 15.7 degrees Celsius. 15.7 times 2.09 times 150, just backtracking across through there, 4921.95. And again, that's grams and grams crossing out, degrees Celsius and degrees Celsius. Joules is my final answer. The next one, a chunk of ice, is at a temp of -75. We're going to put 546 calories into it, which the ice is going to absorb to make it warmer. And we have to calculate the new temperature. There's simply no place to put the new temperature on this round little buddy. But what we're going to have to do is figure out the change in temperature and then bring it one more step. Delta T means a change in temperature. So if I cover up change in temperature, it's going to say to put the heat on top and the mass and the specific heat on the bottom. So how much heat? 546 calories. What's the mass of the ice? 32 grams. What's the specific heat of ice? Now this time I have to look for a different specific heat because this doesn't have to do with joules, this has to do with calories. So when I look down here for specific heats, it's the one that says 1 cal per gram degree Celsius. 1 cal per gram degree Celsius. Oh, I guess I have to reread this. Specific heat of ice is 0.5 cals per gram degree Celsius. Because it's a solid, has a different specific heat than the liquid. When I put this into my calculator, 546 divided by 32 divided by 0.5. No need to put the time sign. That'll be a change of temperature of 34.125 degrees. And that's degrees Celsius. But now we have to analyze this. It started out at -75, and if it absorbs heat, it's going to warm up by 34. So it's going to get 34 degrees warmer. If I did 75, -75, and if I add 34.125 degrees, the difference between them, 75 minus 34.125, it's going to be negative 40.875. Negative 40.9, I'll just round, degrees Celsius. That's my new temp because it warmed up. The next one is like a mystery, kind of like the lab that we did. We have to figure out the specific heat of a certain substance and see if it matches any of these. Specific heat is heat on top, mass and change in temp on the bottom. Find a heat, there it is, 3575 joules. Find a mass, 1418 grams. Find a change in temperature. Well, if it's changing from 75 to 57, that's a difference of 18. 75 minus 57, the change is 18. 3575 divided by 1418 divided by 18, and that equals 0.14. 0.14. Let's see, we had joules, grams, degrees Celsius, and nothing crossed out. Joules was on top, so joules goes on top. Grams was on bottom, and it also degrees Celsius was on bottom, multiplied. So I just set those up just the same. 0.14 joules per gram degrees Celsius. Which one does it match? Seems to match mercury. The next one, a student mixed 35 milliliters of water containing HCl at 75 degrees with 105 milliliters of water containing NaOH or sodium hydroxide at the same temp in a foam cup calorimeter. The temperature of the resulting solution increased to 95. How much heat in kilojoules? In kilojoules was released by this reaction. We'll assume the density of the resulting solution was 1 gram per milliliter. So what are we after? We're after heat. Heat is an mc delta T. They don't tell us any masses, but what they tell us is the solution is going to have a density of 1 gram per milliliter. So however many milliliters there are, that's how many grams we have. 35 plus 105 is 140. Our mass is 140 grams. Specific heat, we have a couple specific heats to choose from, but we really don't have a choice. They clearly said they wanted it in kilojoules, so we have to find the specific heat that relates to joules. This is liquid water, 4.184 joules per gram degree Celsius. Finally, the change in temperature. It says it started at 75. The temperature of the resulting solution increased to 95. 95 minus 75 is 20 degrees Celsius. 1 140 times 4.184 times 20. Enter. That equals 11,715.2. Now let's see what units. Grams, grams, degrees Celsius, degrees Celsius. That would be joules. Is that what they wanted to know? Close. They wanted to know kilojoules. And so what we need to do is make the next step. I have to multiply it, do some dimensional analysis or a conversion, but I'm going to multiply it by what I want over given. What I want to know is kilojoules. What I was given was joules. See, that's where it's given. What's the relationship? Well, 1 kilojoule is 1,000 joules. In other words, I have to divide by 1,000. If I move that over 1, 2, 3 decimal places, 11.7 kilojoules.